Good afternoon, respected teachers and professors. Today our group going to present about flowing pipe, laboratory 7, which our lab supervisor is Ajahn Phairat. This lab will be presented by me, Narongsak, Sarita, and Premraphi. The content will be consist of 5 categories: introduction, theory, objective, experiment, result and calculation, discussion, and conclusion. So let's start with introduction and theory. There are 2 types of flows, which are laminar, transition, turbulent. This flow can be determined by using Reynolds numbers. During the flow, there are energy loss, which are from the fittings, pipe length, roughness, or valve, which this of energy loss can result in pressure drop. For the frictional loss, we can calculate it by using the right and smooth pipe. We can use the left part for the laminar and turbulent. There are also the loss of this from the sudden expansion and sudden contraction of fitting and valves. For the upper part or the features is a sudden expansion and the lower feature is a sudden contraction. The sudden contraction can calculate from HFC, and for the expansion can be HFE. For the fittings can be HFF. When we combine for the overall, we can get the HF from the sudden expansion, sudden contraction, and fittings. These are the key values for the valve and fittings. So for venturimeters, venturimeters is the device that used to reduce the friction from the lower or smaller of the pipe to the bigger. These are the binary equation and continuity. When we combine these two equations, we can get V2. Usually V2 is a large or bigger value than V1. So we need to add CV, which is the coefficient of venturimeter.
Objective. First one to estimate fusion loss when fluid flow in pipe and or passing fittings. 2. To estimate energy loss due to sudden expansion, sudden contraction, and flow resistance. 3. To study different methods of flow rate measurement using in industry. 4. To estimate discharge coefficient of different devices used for flow measurement. 5. To obtain flow rate measured by an olefinometer and a venturimeter and compare them with the flow rate obtained from a rotameter. Experiment. Material and apparatus. In this experiment, we used Pipe4Wizard program from www.pipe4.co.uk, and this is a picture of the program. Experiment. First step, we open Pipe4Wizard program, and then we set a pipe detail layer, pipe material, diameter, length, fitting, and then after we put all of information, click calculate, then the result will show in the program. Result and calculation. Fixed data. First we set the pipe detail, internal roundness. In this we set is a 0.046 mm, and pipe material in this is a steel, and internal diameter 25 mm, and length 15.24 m, and elevation change is a 0.305 m, and flow is a 378.541 liters per minute, and the fluid type we select the seawater at 10 degrees Celsius, and then we set the pipe fitting. In the pipe fitting, we have one standard bend, 2 pipe bend, 1 reducer, and 1 check swing, and 2 global valve. And after we set it already, we click calculate pressure drop, and then we got the result. In this, we got a 4 type is a turbulent. Reynolds number is a 238,719, and the friction loss is a 0.024. Fluid velocity is a 12.853 beats per second, and in this is pressure drop is 416.4485. Experiment data. In the first one, we change pipe material, first to the aluminum and second to the galvanic steel. When we change pipe material, the flow type, Renault number, and the fluid velocity is the same. It's not changed. It's changed only friction factor and the pressure drop. Second one, we change length. We change length to 20 meter and 25 meter. In this one, flow type, Renault number, friction factor, and fluid velocity all the same with the fixed data. It change only the pressure drop. Third, we change the fluid type. We change to heptane 20 degrees Celsius and the second one to olive oil 20 degrees Celsius. When we change the fluid type, the Renault number is changed and the friction factor change and pressure drop change. Same only the flow type and fluid velocity. Next one is the change flow rate. This one we change flow rate to 450 liters per minute and then 500 liters per minute. In this one have a change in the Renault number, friction factor, fluid velocity, pressure drop is the slight change or only the flow type that the turbulence same. For the discussion part, because of the COVID-19 situation, so we cannot do this experiment in the laboratory, so we have to use the pipe for research program for simulation instead. And the thing that we will consider is pressure drop, and the factor that affect the pressure drop, we consider 5 factors. The first one is pipe material, the second one is pipe length, the third one is internal diameter of the pipe, the fourth one is changing the flow rate in the pipe, and the last one is the fluid flow in the pipe. So let's begin with the first factor. The first factor, pipe material change. We have changed into steel, aluminum, and galvanized steel. So different pipe material will have different internal roughness. When the internal roughness increase, then the pressure drop will be increased as well. The second one, the pipe length, we change into 15.24 meter, 20 meter, and 25 meter. With the longer pipes, will cause more the pressure drop than the shorter pipe. The third one, because of the limitation of this program, we have to pay for the license, so we can change the internal diameter. So from the theory, with the smaller internal diameter, it will cause more pressure drop than the bigger internal diameter. For the fourth one, for changing flow rate, with the higher flow rate in the pipe, will give more pressure drop as well. And the last one, the type of fluid flow in the pipe, we change the fluid into 3 types. The first one is seawater, the second one is heptane, and the last one is olive oil. With the different fluid, we will have different viscosity depending on the fluid, right? So the more viscosity, it will cause more pressure drop in the pipe. And for conclusion, the 5 factors that cause more pressure drop. The first one is pipe material. For the pipe material, more internal roughness will cause more pressure drop. The second one, pipe length, with the longer length will cause more pressure drop. The third one, the internal diameter, with the smaller internal diameter will cause more pressure drop. The fourth one, the flow rate, with the increasing flow rate will have the more pressure drop. And the last one, with the fluid in the pipe, with the more viscosity of the fluid will cause more the pressure drop in the pipe. Thank you for listening to our presentation.